So if you saw the last video, I hardened and water quenched a couple of pieces of coil spring and hit them with a big hammer. So here are the two original pieces, quenched at different temperatures. If you want to see more about that, check out the other video. And then I hit them with a BFH, big hammer, and snap these clean off. The difference in heat treats resulted in a difference in grain structure, and one was incredibly brittle, and in fact the leftover pieces were just crumbled. You can see the edge was incredibly jagged. This one broke a little cleaner. This was quenched more around the decalescence temperature, and a little more promising, but didn't get as hard as this one. So anyway, the purpose of this video is to take a look at these again after they've been tempered. So I tempered these both in the oven at around 400 degrees Fahrenheit, and I did so on 2 cycles of around an hour 30 each. So hopefully we've tempered these to the point at which they don't break quite so easily. Let's find out if that is in fact true. What I'm going to do is load them up in the vise and hit them. So here they are, post tempered. Won't waste any more time, and just get this in the vise, leave it out about an inch, and see what happens when I beat the crap out of it. So we'll just take a gentle pass at first. I held on pretty well. Keep going. And eventually we managed to break it, but that took a little more, I believe, than the initial pass. That was the one that was treated at a lower temperature. And this one is the one with the coarser grain structure that was heat treated at a much higher temperature. So we'll do the same treatment on this, a couple of light blows. And I felt that one start to break apart before we really gave it too much. So the tempering really didn't have much effect on this. I think if I'd have hit it hard from the start, it would have broken quicker. Let's just test that theory. Give it a harder whack from the word go. Oh, here we go again. Nice big hard whack. First time. Oh, held on a little better than I thought. Let's give it another go. Beat that one pretty hard. So the tempering definitely achieved something. The fact that this isn't crumbling in the same way as it did pre-temper tells me it definitely got something. What I need to find. So here's the other one. I found it buried behind the welder. So we're just going to give this the same treatment I just gave the last one. Give it a good hard whack from the start and see where that gets us. And again, held up to a decent whack. And another one. And another one. So the temper on this was much better. Well, I guess really it was the same temper, but the initial heat treat was much different. So the grain was much finer. So I think what we saw in that last test was the importance of the temper. Certainly, it's definitely one thing. These two pieces broke immediately yesterday when hitting them with the big hammer. Today they took a few more bashes, and certainly towards the end there, I think they took some reasonable abuse. Certainly performed much better than the untempered. I think the other lesson to be learned here is what happens in the original heat treat in terms of grain size, and maybe the importance of correct heat cycling before the final quench. When I did these, I literally just did I did no heat cycles. I just did a quench from a given temperature after working them. And I think that certainly played a part in making the grain size of this piece much bigger than this, and despite the tempering, this was still quite brittle. The one with the smaller grain stood up a little better, I think, to the abuse. So still a lot to learn here, a lot of study to understand the real metallurgy of what effectively is junk steel here. So I will not stop experimenting with this. I will continue on and see if I can find a way before I get to the end of the coil of making this work. So keep watching, and I'll get back to you on any advancements I make in the heat treat of this, and see if we can make it useful.